Hi, my name is Prabha. I'm here to present a paper on brain stroke prediction using machine learning algorithms. As we all aware, brain stroke disease is cerebrovascular disease and it is life-threatening medical condition. And as we all know that it is increasing day by day. So brain stroke occurs when blood supply to brain is interrupted and when there is a limited supply of oxygen or nutrients to blood cells. So this may lead to severe disability or even it causes death. So changes in lifestyles, dietary patterns are aided to brain stroke disease. So there is a need of accurate, reliable, and feasible system to predict such diseases and to predict the brain stroke in early stage and to get the proper treatment for it. So also in the countries with the huge populations, it is difficult to diagnose each and every person and provide effective treatment and to provide the early treatment. So, several machine learning techniques have been introduced to help healthcare industry and diagnose brain stroke disease. Okay, so let's look at the problem statement. So, major challenges in stroke disease is its detection. So, patient comes to know about stroke disease at later stage, where the disease is already amplified. And for a doctor to predict the brain stroke requires sufficient knowledge and experience. And the other challenges that we see is data complexity. And so patient data for stroke prediction is often vast and diverse. So in order to extract the meaningful information from this complex data is significantly challenged. And and also the feature selections. There will be a huge data sets. So in order to uh, get the proper features from those data is a really challenging task. And yeah, these are the problem statement. These are the field challenges that we are facing. So let's look at the methodology. So I have used experimental type of machine learning algorithms such as random forest, decision tree, k-nearest neighbors, ADA boost, LT boost, and SVM algorithms to build a model. So in the data pre-processing, I have worked on addressing the missing values, duplicate values, and handling the outliers and handling the imbalanced data. So in order to handle the missing values, I've used KNN algorithm, and since there were no duplicates, I've not handled them. And in order to handle the outliers, I've used three thresholds and have handled the imbalanced data with a smooth techniques. And using feature engineering techniques, I've converted the categorical values to a measurable numerical values and some numerical values into the uh, some defined range of values. And as I mentioned, I've also used the machine learning algorithms, logistic regressions, random forest, and decision tree, KNN, SPC, all these algorithms, and I've applied five-fold cross validations on each algorithms to check to get the best performance out of all these algorithms. So let's look at the flow of the model. So the diagram shows the flow of the model. The first is data pre-processing. In the data process, the pre-processing have worked on missing values and cleaning the duplicate values and balancing the imbalanced data using this mode. The next comes the exploratory data analysis. I have plotted the pie chart, all those diagrams to analyze the data in the exploratory data analysis. The next comes the train and test split. So in this stage, I have split the data sets into train and test data sets, and I've worked on testing sets, and then I have tested the model on the training sets. So next comes to algorithms. I have used many algorithms such as logistic regulations, random forest, KNN, and SVC, and um, many other algorithms in the stage. And the next comes the smooth. So in order to handle the imbalanced data, I have used this mode technique, and next is model development. So the next stage is the model validations. I have done the model validations on all the algorithms, and the next is prediction on new data set. So this is the flow of the model. So next comes the results and conclusions. So our thesis explained the application of various machine learning algorithms to predict if a person is likely to have a stroke or not. So through extensive experimentation and evaluation, we developed or fine-tuned various models and capable of accurately identifying and classifying whether the person gets the stroke or not. So these results demonstrated the effectiveness and potential impact of these models and streamlining and improving the prediction accuracy of stroke prediction. So the XGBoost classifier used for modeling exhibited strong performance in classifying the stroke. So as you can see, XGBoost classifier outperforms all other models and gives the highest accuracy rate on training data set. So the ROC AOC score is 0.99%. So here, this is the figure that shows the comparison between all the methods. As you can see, uh, LG XG Boost classifier is giving 0.99%. So the other classifiers, other methods are giving less than the XG boost. As you can see, KNN is 0.97 and Araboost is 0.98. So next come to a future work. So in the future work, it can be enhanced by developing a web application based on random forest algorithm as well as using a larger data set as compared to the one that we used in this analysis, which will help to provide a building upon a progress made. So this research work can